account, but if I wanted, I could just open connect the dialog, and I can also establish another connection. And I have several ways to connect to my Azure storage accounts. I can use a storage, for example, connection string. I can use just a storage account name and key. I can basically just use a resource via the Azure AD, so Azure Active Directory, or I can use my Azure account. When I do the Azure account, I just need to tell which environment do I want, if it's the what we call the global Azure, or if I want one of the specialized versions of Azure storage, like Azure Gov, for example, or Azure China, or Azure Germany. So in my case, I could just say Azure, you just press next, and now this will just show you, okay, the standard authentication to get to your Azure storage account. So you just go there, just put your Microsoft account here, your Azure AD, and there you go. You will be connected like I am here connected with my credentials. Now, I can just basically expand, okay, this here. You see some of my storage accounts that I have in this demo account. I have here the AZ videos. I can see containers, shares, queues, and tables. I will go for containers. I have here already a container, which is called demo. But if I wanted, I can just right click and click here to create a new blob container. It's as simple as this, and you just need to put here like demo 2, for example, and we have here a new container. And now what we can do with the Storage Explorer, well, it's the standard thing that you're expecting in such a tool. Like, hey, I can upload a folder, or I can upload some files. I can just select here some files to upload to this blob container. I can also right click on my blob container and just said, oh, what is the public access level that I have on this container? And well, it's what we see also on the Azure portal. So no public access. So this is the private one. Public read access for the container and the blob, or just for the blobs. I'm okay with no public access, so that means that it is totally private. If I select here for example, my MCT logo, I can copy, okay, the URL of this MCT logo. And if I open a browser, okay, and if I just do this in the browser, and if I just zoom in here, you can see that, well, this is the URL that I'm using. So AZ videos, blob.core.windows.net, the name of my container, and then the name of my blob. Well, I just getting an error says that this doesn't exist, but we know it exists. We were there, right? So, well, because this is private, so we can't see this. But the Azure Storage Explorer has an amazing feature, which is creating a SAS token, so a shared access signature just from here. It's super simple to do. So we just do this. We just say, okay, this is the starting time. This is the ending time. I just want to read. You could just put other permissions if you wanted. For me, read is enough. I just do this, and there you go. You have here the new URI of this. So I can just copy this. I can now open the portal, and I replace all this with, okay, my URI with the shared access signature, and then bam, there you go. Okay, and if you see the URL up here, it is exactly the same, but this bit here, okay, we basically have the shared access signature, and you see how easy it is to create this. So I really love working with the Storage Explorer, because to create this kind of things, I just don't need to go to the Azure portal and do this in the Azure portal. I can just do this straight from the Storage Explorer. And of course, the Storage Explorer also allows you to work with file shares, with queues, with tables. If this is a storage account that is a data lake, so a Gen 2 data lake, you can also work with your data lakes in here. So it's pretty cool what you can do with the Storage Explorer. So a single Azure subscription usually comes with the possibility to be created 200 storage accounts. If you have need to have more storage accounts, you can also open a support case to increase the limits of that subscription. But there is a hard limit at 250 storage accounts. If you still have the need for more, even if it's a hard limit and you cannot have more in a single subscription, you can always create other subscriptions and then grow the number of your storage accounts that way. An Azure storage account will have a set of services that we're going to see, but they are durable, secure, scalable, and managed. So managed basically because Microsoft will manage all of this. It's not like a network storage or a storage device that you have in your own company where you are responsible for managing those. If a hard drive breaks, well, you have to have spares around and you need to deploy those spares as fast as possible. There is also not the need to basically procure new hard drives because you need to scale the size. So all of that, it is managed by the vendor, in our case, Azure. And then, to be honest with you, I really like that approach. There are certain people that say, oh yeah, they don't want to lose the control of doing that kind of operations. But for me, I see that as, what do I get business-wise for my company from doing that? I don't get anything. It's a lot of work that I have. We might have more people doing this kind of work that we could just take advantage of those persons and just put them to do other work that could be more beneficially to the company. So the company could get more out of the same number of employees. Also scalable because, like I said, if you need more, hey, look, you just can get more. You just need to put more storage accounts, and also secure because, well, by default, data written in the storage account, it is encrypted by the service. So Microsoft has a Microsoft managed key that encrypts the data at rest. If you want, you can even change that key to your own key. So you can bring your own key to this and you can switch the encryption key. Then durable, because as we're going to see, we have several methods of redundancy that will ensure that our data, it is safe even in eventual hardware failure. And we can even guarantee that your data will survive even if a full region it is out. So even in that case, there is the possibility. Of course, that always depends on the redundancy method that you're going to choose. But hold on a little bit on that because we're going to have a slide exactly to talk about that. So what kind of services do we have? So I have blobs, files, queues, and tables. So blobs, what are blobs? Blobs is a massive scale object store, and I can host and store text or binary data. And this also has the possibility to support Azure Data Lake Storage Gen 2. So the Generation 2 for Data Lake uses Azure Storage. It's no longer a specialized service. So we can just use this, and it makes all the sense. It's a storage service, so it doesn't make sense to have a different service for this. And then we have files. So I can manage file shares for cloud and on-premises deployments. And this is very useful, especially in lift and shift scenarios, because blobs, I can only access blobs through a REST interface. So I need to have an HTTP request to upload and download data. With files, even if I can also use a REST interface to do it, I also have an SMB endpoint. So that means I can go to a Windows or a Linux machine and I can create a mapped drive, and then I can just have the drive Z corresponding to a file share on an Azure storage account. So we have that possibility. So as you can imagine, to do basically lift and shift scenarios where we still need to have some kind of common ground between two virtual machines, this can be very, very useful. Then we have queues. So queues is a very simple messaging system that we have with Azure Storage. And I'm saying simple because, to be honest, you're going to read, oh, it's for massive scaling, etc., etc., etc. But look, to be honest, if you really have those massive scaling needs, well, there are other services that will probably fit you better. One great example of that will be use service bus queues or service bus topics, depending, of course, again, on your requirements. Those, yes, they are for massive scale, all of that. But in here, look, I use this a lot. Like I already told you, in a lot of customers, I use this. It is a great service, but it's just not for specialized workloads, messaging workloads. For that, you have a specialized service. It's what it is. Then table storage, kind of the same thing as queues. This is a NoSQL store for schemaless storage. But again, like I said, there is another service called Cosmos DB, which basically will give you a proper NoSQL experience with a lot of more features and also a lot of more throughput that we just don't have in an Azure storage. In terms of storage endpoint, usually our endpoints will always start with HTTPS or HTTP if you still use that. And then my storage account, basically the name of the storage account that basically you call. In my case here, my storage account is called my storage account. And then dot the name of the service. And the name of the service can be blob, table, queue, or file. Then .core, .windows.net. So those are the endpoints for all the services. So interact with Azure Storage API. So how can I do this? I can use the REST API directly. So if you're like in .NET, you can just create an HTTP client object and just start to use that object to do HTTP calls. If you're in JavaScript, the corresponding one, again, for the same thing for Python, Java, JavaScript, etc. Or I can use client libraries. So there's a set of client libraries that help you to do this kind of work. And there is SDKs for .NET that, again, facilitate a lot the way that you interact with your Azure storage account. So that's more the way that developers, okay, will need to interact with this, but still is good to know. So an Azure storage account is basically the source object that I have here, and is the one that I'm going to use to house data objects such as files, blobs, tables, disks. So all of that can be stored in here. Again, like I said, I can do HTTP or HTTPS connections. Advise you to only allow HTTPS. I'm even go a little bit further, and in my deployments, I even like to use Azure policies to check if all my storage accounts are created that way. And if not, I don't allow them to be created. And the ones that are existing, I will be marked, okay, as non-compliant. So that means that in the future, in a very, very quick future, someone needs to reconfigure them. Like I said, well, we need to do that very carefully because you might have a reason why there's still HTTP and HTTPS. So they still allow both connections because sometimes we have legacy workloads that, well, let's not comment on that, but there's some issues and only allow HTTP. So what about data redundancy? So data in Azure storage accounts is replicated, always replicated. So that ensures that it's always available. It can be replicated within the data center or to other regions. The idea is if one of those copies become inaccessible because a hardware failed, a problem in the network, a logical issue. So what happened is that we still have other copies of our data that will survive. So for this, I have 6 different types of data redundancy today. The first one is local redundant storage, also known as LRS. LRS stands that you have at least 3 copies of your data within the same facility. So that means the same physical data center. Those copies are always in sync. So they are synchronous. So when you send through the REST API a file to be hosted there, that file is copied to the first copy, second copy, and third copy. And only when all of them are stored, they are guaranteed, is that you get an acknowledge that, yep, your file is good. Okay, we got it. So it's only when you get an acknowledge. You're also not going to have zone redundant storage. But when you have, you can use this, and of course guarantees a lot more availability, because if one zone is down, that means that the other 2 might also be up. So they might not be down because they have independent power, independent cooling, and independent network. So if the problem is one of those things, the chances of them to survive are quite high because they don't depend on the same hardware for networking, power, or cooling. Then I have the geographic redundant storage, also known as GRS. So GRS, what happens is that I have 3 copies like local redundant storage, exactly like the same thing. But then, asynchronously, there is a copy being made to another region. That other region that I have will then host 3 more copies of your data. It is quite good because, well, if there is a major failure in a single region, well, you can still have your data hosted in the other region. So if that's the problem, Microsoft will redirect the traffic to the other region and your data will still be up and it will still survive. Basically, your workloads that depend on that will still be able to survive. What region does it copy things? Is that randomly? No, it is not. So this uses a feature that we have in Azure that is called pair Azure regions. So if I put data, for example, in West Europe, the copy, so my data will be geo-replicated to North Europe, because North Europe is the pair region for West Europe. So you have to go to the Azure documentation and check very carefully the region that you're using. What is the pair region, so that you can see if you can use GRS or not. Like I said before, we might have some market regulations or governmental regulations around where I can or I cannot host my data. So if the data is in a different country, well, you might be careful with that. You might not be able to use GRS. Not in a technical problem. It's not a technical issue that you can't use. It's more on a legal reason. Read access GRS. It is exactly the same thing as GRS. The only difference is that I have a secondary endpoint that my applications can use, but of course, only to read. That's only possible to be used just for read. Okay, so it's time to do a demo, and I'm going to explain on the storage account creation, when and how we have to select the specific redundancy for our Azure storage accounts. Okay, so let's create another storage account. So let's create here. Let's type, okay, storage account. When I'm here on the basics blade of my storage account, so the usual, I just need to select what is the name of my resource group that I wanted here. I will just call it AC videos. I need to type storage account name. I will try AZ videos. And then I need to select the location, the performance, the account kind. And then I have here this bit that says replication. So this one here. So this is where we have the option to select what is the type of replication that I want for my storage account. And in this case, by default, this is selecting read access geo-redundant storage. But of course I can click here, and as you can see, I have all the other options available here. Local redundant storage, zone redundant storage, geo-redundant, but also geo-zone redundant, and the read access geo-redundant storage. Because in this location, all of those are available. Of course, if, for example, I switch this to a region that doesn't have availability zones, like, for example, Switzerland North, I can see that in here. So you see that not all the replication options will be available for you. So you have to select your location that you know that will have the options that you need available. So you see I switched back to East US, and now, yeah, I have all the options here available. And then, well, creating the storage account, the rest of the options is the usual. There's no changes. So, but it's just this replication mode here that you need to properly select the one that you want. So high availability and disaster recovery. So when an account failover works, so when you configure a storage account to use GRS or read access GRS, the client, okay, writes the data to the primary endpoint or region. Then the data is automatically replicated, okay, in an asynchronous way to the secondary region. So this is what happens in the back and happens in an asynchronous way. So be careful with this, because Microsoft is aware, and they even call you to the attention of this. Might be a loss of data. Okay, it can happen because this scope is in an asynchronous way. So connect to your Azure storage account. How can I connect my storage account? So I can use the security keys. So when you create an Azure storage account, you created 2 keys. You didn't saw that, you didn't define the keys, they are auto-generated. So you can go there, and I have a slide, the next slide is about that, and you can access those and you can connect through the keys. I can also use a REST API, so to connect to blobs, etc. And I can just go there through the REST API, issue a REST request, and you can start to do operations on your Azure storage accounts. Or I can use connection strings. So usually connection strings are very used for and by developers, and they basically create a .NET Core application, needs to interact with some data. They grab the connection string and they use that connection string to connect to your storage account and then interact with your storage account. So now let's talk about storage account keys. So when it comes to storage account keys, so by the way, if you want to go to this bit, you just go to your storage account, and then under settings, you have an option that says access keys. And if you basically can go there, you can see that you have 2 keys, key 1 and key 2. So they basically have the same value. There is no difference in terms of value. So it's like, oh, key 1, I can do more things than key 2. No. Okay, they have the same rights. There is no difference on this. The big advantage of having 2 keys is to do what we call key rotation. So usually what happens is that I give key 1 to my application so that they can access my storage account. And I have several applications using key 1. And then it's a security best practice that says that from time to time, well, you should rotate the keys. So that's the process of going to each one of those applications and say, hey, look, please do not use key 1, now use this one, and that one will be the value of key 2. And so they will replace that. And when you know that all the applications have replaced, so they rotate their keys, so now they're using key 2 instead of key 1, you can come to this UI and you can just basically regenerate your key 1. The regenerate of the key 1, so that means that the old one will stop working right now. So when you do the regeneration, it basically just stop. So imagine that there was one application that you don't know that were using key 1, or they forgot to change the key. So that application can no longer access your storage account. And then a new key, okay, is going to be shown. And there is no way to recover key 1. So if you want to like go back, there is no possibility to go that. So basically, for security reasons, it is quite good to do this. Of course, there is even more things that we should consider in terms of security. There are other services that you can use together with this to facilitate that rotation. A great example would be Azure Key Vault. But basically for now, in terms of keys, this is it. Okay, so it's very used to do this key rotation. Okay. Another way to have access to your storage account is also to use shared access signatures. And I can do service level that is specific for blobs or for files, shared access signature, or I can do an account level. An account level, I can just say, hey, for blobs and files, and I can use the same shared access signature basically for interacting with those two services. But basically, I typically use shared access signatures for services where users need to read and write their data to the storage account, and that storage account is using like private containers. And the idea for me is just to create this shared access signature. One of the details that I can configure on this is I can configure this just for a small period of time. And so just for like 2-3 minutes, seconds even, is that you're authorized to start to download the file. And after that, well, that shared access signature is no longer valid. That is a great approach, especially if you have a front-end application. And that front-end application, a web app, for example, it will have the links for your storage account. So you really don't want, okay, for those SaaS tokens to be valid for a year, a month, or things like that, because someone can just copy paste that link, send that link to someone else that might not even be able or should have access to the information that you have on your storage account, and that other person can download the file. So even I even go a little bit further on this, and when I use SaaS tokens, what I do is when people click on the download button, they don't have the link there. They access a service in the server side somewhere. I generate the SaaS token, I send the SaaS token, and it just issues the download right away. So when he does this, people don't even see the SaaS token. Well, you tell me, well, if they turn Fiddler on, they will see it. Yes, that is for sure. But this is only going to be available to start download for like 5 seconds, something like that. So it starts the download, and that's it. So they never have time to copy this, send to someone else, and then someone else starts to issue the download. It is really unlikely for someone to have something like that. And look, then you can tell, oh, but they can automate that. I said, okay, yes, for sure. But if you really, really need to protect that much of information, maybe also SaaS tokens might not be the best way. There are other ways. But if they really want to send the data, look, they can always download and have it in their system, and then they can just send it through other services if you're using a non-protected device or something like that. So there's always ways for people to share content that they are not supposed to. So, but let's talking about SaaS tokens, and let's do a demo about exactly Azure storage SaaS tokens. Okay, so I'm in the overview blade of my Azure storage account. Now, I'm going to navigate here to containers, and I'm going to create a new container, and let's just call this container demo. Then I can create the container with certain levels of public accesses. Private, blob, or container. Well, private, I think the name says it all. There is no anonymous access. Blob and container, they have anonymous access, but there is a difference. Is that in blob, you have to know the exact URL of your blob. When in container, you also can access anonymously a blob by using the URL, but you can also list all the blobs inside that container. So that's the difference that you have. In my case, I'm going for container, and I'm just going to create. So now I have the demo container. I will click here, and now I can upload blobs right away from my Azure portal, and I will click upload. So there you go. I can close this. I have my blob here. It's a picture. It's the Microsoft certified logo. I can click under the copy to clipboard. This is the URL of my blob. And now if I just open a browser and I just drop this URL there, you're going to see that it's going to show the picture. So let's do that. Okay, so I have your browser. If I just drop this there, and you can see, if I zoom this, you can see your AZ videos demo. That's the name of our storage account. Then blob core windows.net, which is the rest of the endpoint, and then demo, which is demo. It's the name of our container, and then I have the name of our file, our blob, which in our case is the mct logo.png. So if I just press enter here to do the REST call, there you go. Okay, you just see, just responds, and I have the picture here. It just shows me the picture. Now, let's get back to the Azure portal, and I'm going to change the container permissions. So back again here to the Azure portal. I'm just going to do the exact same thing. So, but now change the access level to private. So let go. There we go. It is done. Then we go back here to the page where I had the blob. And now I'm going to refresh this. I just reissue, okay, the request. And you see, I'm now getting an error saying that, well, the specified resource does not exist. Which, well, we know that it exists, but of course, as a security measure, when we do a call like this, it's not going to tell you that, oh yeah, it exists, but you don't have access. No, it's just going to tell you that this one doesn't exist. But imagine that, yeah, I need to have access to this. So what I'm going to demo now is how can I provide access to someone without that person to be authenticated in any way by using a SaaS token. So I need to go back to the Azure portal. And now here on the Azure portal, I'm going back to containers. So there you go. I have my list of containers in here. And now under settings on your storage account, you have an option here that says shared access signature. So it's under settings, okay? So if I click on that option, I have here a tool that generates a SaaS token. This is good for an ad hoc experience. It's not the optimal experience if you have to create some kind of automation. This is why there are REST calls also to create SaaS tokens. You can also do this using the REST API, SDKs, etc. So I want to allow just my blob service, and I can all of them, like allow, the service, the container, and the object levels. Now, in terms of permissions, well, yeah, read, I need it. I don't need write or delete or add or create. I just want like list and read. That will be enough. Then I can have the start and expiration date time. I will go with the defaults, but of course, look, you should be careful to create, like I said before, a very short window when you're providing shared access signatures. I can even block certain IP addresses. So if you want just a specific IP address to be able to use the SaaS token, you can also do that. And then the allow protocols, if this SaaS token will only work with HTTPS, or if you allow also HTTP. And then to which key from key 1 and key 2 am I going to use to sign this? When you decide everything, and I'm just going to keep most of it as the default, you click generate SaaS and connection strings. Now you have here a connection string using this SaaS token. You have here the full blob service SaaS URL with the SaaS token attached, but I just want the SaaS token itself. So I just copy this piece here, and now I'm going back to the window where I have the request to my picture, and there you go. And I'm just going to attach the SaaS token as a suffix, and I will just basically reissue the request. And as you could see, so there you go, I have access again to my blob, and in this case the blob, it's under a container that is private. But so as you can see, so this is the bit of my blob name, and then all this that you see here, it's all the SaaS token. So this is the version. You have the services that you're allowing. This is the service, the container, and the object that we did. This is read and list. This is the expiration time. This is the start time. This is just allowing HTTPS. And then you have the signature. So the signature was created based on the key 1 that you created. So now let's check about network access. Our storage accounts, if you go to firewalls and virtual networks, we can restrict the traffic only from selected networks. So what I mean is only selected networks will be allowed to communicate with your storage account. That's a great benefit, especially when you have the need to only allow traffic from on-premises. You can have an on-prem network connected with VPN, express route, doesn't matter, with another network that is a virtual network on Azure. And then from that network, you can even peer to another network to have a hub spoke method. But so from those specific networks in Azure, you can block the traffic. Only those networks will be allowed to communicate with the storage account. That means that no other traffic from other sources can be allowed there. We can do this via the Azure portal, as you see over there, but I can also do the same thing from PowerShell or using the Azure CLI. I can also implement advanced threat protection. Advanced threat protection will detect anomalies in your Azure storage account, and then it will notify you or about something that might be happening on your Azure storage accounts. Okay, things like this, that when it detects some suspicious activity that is happening, it will notify you about that. There is a cost for this, so this is one of the features that it doesn't come by default. So there is an extra price for this, but in my opinion, it is something that it is quite valuable. Also, in terms of data protection, there is also another feature for blob storage that is called soft delete. So soft delete protects you against those accidental deletes or an accidental overwrite of a blob. And then, well, you don't have any backups of that and you just don't know what to do, right? So, but if you enable soft delete, basically you can configure the retention period for this. It can go up to 1 year. And you can, between the date that it was replaced, okay, until this retention period, you can go back, okay, and you can recover a specific version of your blob. So let's just see how we can implement this and how easy it is to implement soft delete. So we're in the Azure portal and we're going now to show how the soft delete option can be configured. So we have two options to configure this one. The first one is, let's create a new, okay, storage account. And when we create a new storage account, so we need to say here, yes, this is the resource group where I want to create things. I need to provide a name for my storage account. This name was okay. Then I can go to networking. I could define stuff on the networking, but under the advanced tab, so you see here that under data protection, I have the option to enable, okay, blob soft delete. That by default, currently, it is always disabled. So if you want it, you just tweak this to enable. You can define number of days that you want to the blob to retain. So after 7 days, there is no more blob soft delete option. So this is good, but it's not. It's only for those first 7 days. After that, if you want to recover a file, it would just not be possible. But if you want more, hey, just put this. The top is 1 year, so you can go up to 1 year. So that will be okay. So if I do this and I click review and create, and I'm just now creating a storage account, it will be created and you'll have the blob soft delete option enabled. I'm not going to create now the storage account, but what about, imagine that I have already a storage account, already an existing storage account, and I just want to enable this option, Thiago, because look, I already have a lot of data there, a lot of applications connecting there. I just don't want to create a new one and then move my stuff there. Well, there's no problem on that. So you just need to go to storage accounts, choose your storage account. And now under here, the blob service, you have an option that says data protection. So if I click on that data protection, so as you can see, it is exactly the same option that I had when I was creating the storage account. So disabled, okay, but I need to enable it now. I can define the retainment period that I want. By default, this just puts to 7 days, but you can also tweak this up to 1 year. So let's just drop this to 7 days. You just press save, and that's it. That's how you enable here the blob soft delete. So you see how easy it is to do this. Okay, now that we have talked about Azure Storage Management, let's take a quick... Welcome back, everyone. So let's get started with what are Azure Files. And we know that Azure Files, they offer a fully managed file share into the cloud that you can access via SMB protocol, so the server message block. This will allow you to create file shares and just mount a file share on your Windows machine, on your Linux machine, or even in a Mac OS. So Azure file shares can also be cached on Windows servers with Azure File Sync for faster access near where the data is being used. So talking a little bit about an overview about Azure Files. So Azure Files can be used to completely replace or supplemental traditional on-premises file server or network attached storage devices. So popular operating systems like Windows, macOS, Linux, they can direct mount Azure files wherever they are in the world. So they can be running on-prem, they can be running on other clouds, or even on Azure, of course. So Azure files, they are pretty good for doing lift and shift applications, and they're very useful for this. So this basically, imagine that you have an application on-prem and you need to migrate that application to Azure. And that application is expected to find a file share on the server where it is running. Well, we know that some applications, we don't have the traditional file shares in Azure. So Azure file shares can be achieved by using Azure files. And then you just map that network drive on that machine, and then there you go. Okay, you have it, and you have a traditional file share over there that your app can locally access. It's a mounted drive, so you can just use that one, and it's very, very useful. And I already used this several times when I'm migrating legacy workloads to the cloud. And then later on, we can modernize those workloads and switch from Azure files to blob storage, for example. Also, the simplification that you can do with cloud development. So like I was telling, imagine that there is a shared application setting, and a common pattern for distributed applications is to have configuration files in a centralized location. And then we can have several different instances reading that data from that mounted share. So of course, this can also be used for that. Of course, there are better ways to do this in the cloud today, but hey, if you're migrating a legacy workload, this can be the case. Also, key benefits that we have with this, it's one of them is the shared access. So like I was saying, this uses the standard SMB protocol. So it is not something that Microsoft created specifically for Azure storage and for Azure. No, it's a standard protocol, SMB. So you basically can seamlessly replace your on-prem file shares with Azure file shares without worrying about application compatibility and things like that. So there is no need for that and to worry about that. And all of these features, we get it in a fully managed service. So Azure file shares, they can be created without the need of managing hardware or even the operating system. So this means that you don't have to deal with patching the server OS, critical security upgrades, replacing a faulty hard drive. So all of this, it is not needed. And of course, you can build your Azure file shares and your Azure storage accounts using ARM templates, using PowerShell, Azure CLI commands, etc. So all of this, it is there and is available, okay, for you to use. So Azure file shares can be used to add or replace your company existing on-premises network attached storage or storage areas that you have to provide like the file service. Basically, what you can do is you create an Azure storage account, you create a file share, and then, or you create more than one file share. Then you can create directories and you can create files into that same file share. We have two options when we created the storage accounts, which was standard and premium capacity. There is a big difference in terms of premium file shares. So if you want single digit latency, 100,000 IOPS and 5 gigabits of bandwidth, you need to go to the premium file share experience. If you don't mind to have double digits in latency, to have 10,000 IOPS and 300 megabits of a bandwidth for your file share, which sometimes it's more than enough, to be totally honest with you. You could be, and you can live on the standard performance, which is much cheaper than the premium experience. Then, okay, we also have another service that connects with the Azure file share, which is called the Azure File Sync. The Azure File Sync basically will extend extend your on-premises file shares into Azure. So this is composed by a service in Azure. You create that, but then in a standard box, like a Windows Server 2012 R2, 2016, like a regular server, it doesn't need to be a specialized hardware at all. You can install the sync agent, configure that sync agent with a file share service and the file sync service in Azure. And that will create a local cache that allows you to do SMB, NFS, FTPS, whatever you need. And it's a local share that will cache the most used files for that specific location. So I have here a small diagram where you can see this. So I have a user. The experience for that user, it is the same as usual. He goes to a server which has a network share like he always had, and he requests file A and B. Well, files A was there already cached, so it will be served quite quickly, but B, it's not. So B, it is as a reference to hit, the user can see it, but the file isn't exactly stored locally. So what happens is that the agent, the sync agent, needs to connect to Azure Files and download that on the fly, and then provide that file to the user. For the user, there is no difference whatsoever in terms of the experience, the UI, what he sees. Just his files being copied. Of course, well, sometimes if he just has all the files locally, it might notice because of the speed, but that's it. There is no difference whatsoever. So in terms of terminology that we have here, what do we have? We have the storage sync service. It's represents it's a high-level Azure resource that basically attaches the Azure file share. Then I have the sync group, outlines the replication topology for a set of files and folders. And I have a register server that represents the trust relation that you have to have between an on-prem server and the storage sync service. And then you have this Azure File Sync Agent, which is the download package that I have to install on Azure File, and then we'll do the registration of the server and establish the relationship. So if we see, this is basically the timeline in terms of configuring all this. I create a storage account, I create a file share on that storage account, then I create the storage sync service, and then I create the sync group. The sync group will contain the cloud endpoint that represents the file share and one or more, that maps that single file share, to more than one endpoint. And this is the big tip here, is that I have just one, endpoint that maps basically one file share that can map to more than one endpoint. So I can have more than one register server in the same sync group. So the deployment, it's, evaluate your on-prem system, check if you have all the prereqs in terms of operating system and the file system if it is support. Create the Azure resources, so the Azure storage account, the file share inside the storage account, the sync service and the sync group. Then you install the agent file sync agent, and then you register that Windows server with the storage sync service, and then of course you create the server endpoint, and then your setup will be done. When you're migrating files, so I have customers that they have big volumes of storage and they want to migrate that to Azure. Of course, everyone prefers just to upload this through the internet. It's easy, but sometimes it just takes a very long time. So in our example here, if you have, imagine something between 500 terabytes to 5 petabytes of data. sending that through the internet, even if you have a proper internet connection, it is going to take a while. So that's why Microsoft has the data box service, that they ship you devices that can be 1 to 5 hard drives. It can be one data box or another device that's called data box heavy. The data box heavy can go to 1 petabyte in storage. So Microsoft sends you a data box heavy. It's a big, like a small shopping cart full of hard drives, and very heavy, really heavy. And you can just attach that power network and you copy the data. Everything is encrypted. Then you send that, you ship basically by like DHL or UPS, something like that, to Microsoft. They copy the data and then they sanitize that device so that it can be reused by another customer. You can also do and use something called the import-export service, where you use your own devices. Or you can use AZ Copy. It's a tool, AZ Copy. It's a command line utility to upload your files. But that usually, if you have a proper bandwidth connection, and if you don't have petabytes of data. If you have petabytes of data, sending that through the internet, I'm not saying that's not possible. It's just going to take a while. Connect to the Azure file share. So I don't need the file sync like I was telling you. I can just do this directly. Okay, it's another option that I have. So I create a file share and I can just hit connect, and you can see there they even give you the commands to execute. Let's do a demo. Let's create an Azure file share and let's see how we can easily do this. Okay, so I'm in the overview blade of my Azure storage account and I'm going to create an Azure file share. So I have my 4 services in here: containers, file shares, tables, and queues. Of course, I want to click under file shares. And then on the top, you can see this option that says plus file share. So let's click on that so that we can create a new file share. We just need to type a name, type a quota. I'm just going with 5 gigabytes. It's more than enough. And I'll just click create. As you could see, this is immediately, there's no waiting in here. I have a file share. Now, if I just click on that file share, so you see, I don't have any files in here yet, but I have a button there that says connect. Connecting to this, it will give me my experience to connect to Windows with the drive letter Z. You can even change the drive letter here. It will update basically the command that you have to execute. Here on top, I have 4 tabs because I can do this, and I have the commands for Linux and for Mac OS. Okay, so one or the other, you could just mount this as a mapped drive in your system. So what about securing the access from on-premises? So I can limit the access to your on-premises networks. What I need to know is your public-facing IP address. Then I can issue a small PowerShell script, and I can do this using this PowerShell script, or I can also do this, of course, through the Azure portal or through Azure CLI. So what I need to do is, under firewall rules, I need to establish a new firewall rule for a specific storage account, where I just will allow just a specific range or a specific IP address to access that specific storage account. I can also require the access to be always encrypted. So every time that I'm doing a transfer to be required, so I will only allow HTTPS traffic. And you see here an example, this storage account that has the secure transfer requirement option enabled. So this will make sure that all the traffic needs to be encrypted in order for file to be uploaded or downloaded to storage. So now let's check, let's do a small demo, and how can I configure this security? So I'm here in the overview blade of my storage account, and I just need to go here to the option that says configuration under settings. And now, as you can see here, I have this option that says secure transfer required. So if I have this enabled like I have here, only HTTPS traffic it is allowed in our storage account. If I turn this to the disable mode, that means that I will always also allow HTTP. And I already talked about this. It is just not recommended, so it's only like a last resort if you really have a legacy system that doesn't allow HTTPS traffic. Let's switch gear a bit and how we can better secure Azure storage and how we can monitor availability and performance. So speaking now about managed and unmanaged disks. When we need to store files and use those files directly from a virtual machine, we need to create a disk. That disk can be managed or an unmanaged disk. We're just going to see what are the differences. But also, I have different disk roles. I can have an operating system disk that is just one disk per virtual machine that, as the name says, it will contain all the operating system data, so it will be the OS disk. And then, depending on the tier, the SKU of the virtual machine, I can have several data disks. And I'm saying several because that's the number. It is what depends per virtual machine. I can have virtual machines that can only host 4 data disks and others that can go up to 64. And then I have several variances in between. Also, every single virtual machine has a temporary disk. That temporary disk, it is local storage that exists in the host of the virtual machine. So if for some reason you deallocate your virtual machine, so you stop the VM and then you start the VM, your virtual machine can start in a different hardware, in a different host. That is why the temporary disk, it's called temporary because it is local hard drive. So when you run this in another host, because you just swap machine, the data that you had on a previous host, it's not going to be copied, it's not going to persist. And that can be a problem if you store valuable information and information that you need. This is why this disk should only be used for short-term storage application data like page files, swap files, like for example, a tempdb from SQL Server. So things like this that you should store there because you can always recover them. It can be like cache, for example, too. If you reboot your machine, well, you always need to restart that and recreate that. So it is not something that you're going to lose. Then let's talk about managed and unmanaged disks. So today, the best practice is just go for managed disks. And I have to say that I don't even consider anymore unmanaged disks in my scenario, unless I have to support, of course, all deployment that it's under unmanaged disks still. So scalability, I can have 50,000 disks of each type, and I have standard disks, premium disks, ultra disks, and even in standard I have standard HDDs and standard SSDs. So there are 4 different types. So I can have literally 200,000 type disks per region. So if you're using 5-6 regions, imagine the number of disks that you can have. It is astonishing, the scalability that we can have with this. Even if you need more, just create other subscriptions to do that. Managed disks also supports a 5 nines in terms of availability. That's also a very, very good SLA that we have. It's also integrated with availability sets and availability zones. So when you place your machine in availability set, the disks will also follow that best practice so that they are not stored in the same hardware, just like the virtual machines. Same thing goes okay, for availability zones. The disks will be created in that zone. Also support for Azure Backup. So Azure Backup natively supports managed disks, including managed disks that are encrypted. So natively you have that integration. Also, you can use role-based access control to provide access to specific users for your disk. So again, big advantage that we also have on managed disk sizes. Also, support for encryption. So you can encrypt it by using the Azure Storage Service encryption. So those are always big advantages that we have on using managed disks. Now let's see unmanaged disks. So an unmanaged disk is stored in an Azure storage account, just like the managed disks are too. It's the same thing. But the big difference in this unmanaged disks, this was the default until a few years ago because we didn't have managed disks. So we had to manually create the storage account, create a container, and then store our unmanaged disks. We didn't even call it unmanaged disks, to be totally honest with you. It were disks. So we just had to put this disk inside that storage account. Now, we need to consider something. One single storage account can handle how many IOPS? 20,000 IOPS. So if we go to the less performant disks, standard HDDs, they can go up to 500 IOPS. So you literally can only have 40 disks running at full speed in a single storage account, because if you have more than 40, you're just going to be started to be throttled if all the disks require full performance. So we always needed to have very carefully about the placement of our disks. We were always playing with this. We had Excel files to control where disks will be placed. When I needed to create another VM, okay, how many disks do I need? Oh, you need 4 disks. Okay, where should I place them so that I will not have a bottleneck in terms of the performance of my storage account? So it was always this kind of stuff that we had to do. This is why I said this was really unmanaged disks, okay? So all of this I had to think about it, okay? Also, I must also manage the security and the role-based access control at the storage account level instead of each individual disk like I do with managed disks, okay? So because unmanaged disks don't support all the scalability and management features that you have seen for managed disks, they are no longer the best practice. So you should consider using them only if you want to manually set up, manage data for your virtual machines and storage account. And like I said, well, if you still have some old deployments and you need to basically support those. But of course, I will advise you to migrate to managed disks. Managed disks in some parts can be a little bit more expensive. You have to be careful with the sizes that you put. But in the long run, to be totally honest, the manageability that I have with that, it is so much better that I don't even consider it a thing to think about unmanaged disks today. Also about encryption at rest. So all the storage, it is encrypted at rest by default. So by default, there is one master key per account, and that master key, it is managed, okay, by Microsoft. So Microsoft does that for you. Again, you don't have to worry about anything in here. Well, there are some practices in terms of security that requires you that you should control that key. So what happens is that optionally, you can protect and create a master key, let's just say in Key Vault, And then you can use your own key to encrypt your Azure storage account at rest. So you just need to say, yeah, I want to use my own key. You select from the key vault. You select which key vault you want to use. And then what is the encryption key that you want to use. And basically, after this, your key is the key that is being used to encrypt and decrypt the data in that storage account. So let's do a demo exactly about this. So how can I use my own encryption key? So how can I set up my own encryption key to encrypt data on my Azure storage account? Okay, so we are here on the overview blade of the Azure storage account. We just go to encryption and we can check here that our Azure storage account is using the Microsoft managed key to encrypt at rest all our data. If I want to use my own key and basically lifting the bring your own key scenario, I can check here where it says customer managed keys. I could just enter the URI where my key was stored, or in my case, I will select this from a key vault. I click here, select the key vault. I go, okay, yeah, my key vault is in this subscription. This is my key vault. I only have access to this one, so I'm just going to select that one. And then I have here the option to select the keys. In my case, I already have two created keys. I can just select this one. It's a demo one. If I didn't have a key, I could also, from this UI, create a key. But I just want to do this. I will just press select, and now don't forget to press save. So just press save. This takes a few seconds. And after that, so all the new data will be encrypted with the new key. All the old data, eventually it will also be encrypted with this new key, but it kind of depends on the size of your storage. If you have just a few gigs, it will be quite fast. If you have petabytes of data, terabytes of data, yeah, it's going to take a while until all the data it is encrypted with a new key. Okay, so let's talk about Azure storage encryption and disk encryption. So there is always a huge confusion about these two topics, but with Azure storage encryption, so all Azure storage accounts and the resources that they contain, they're going to be encrypted. This includes page blobs that then back up the Azure virtual machine disks. When we talk about basically disk encryption, we are talking about using like BitLocker for Windows, dmcrypt for Linux, that will provide an operating system-based encryption solution that can also integrate with Azure Key Vault because we need a key. That key can be stored on Azure Key Vault. Then we also have to understand some of the tools that we have available for troubleshooting Azure. So in the Azure portal, I can configure some metrics that can monitor the performance of a storage account. I can view graphs, charts. I just need to select time grain and the metrics that I want to visualize. In here, for example, you can see like total egress that I'm having, total ingress, the average latency, and also the request breakdown. And I can just access those there, and I can start to understand what is going on basically with my storage account. I can also configure alerts to notify me if any of those metrics go beyond a certain level that I think that after that, well, I need to get a warning. I need to understand what is going on. Like average latency, usually it is around 10 milliseconds, 20 milliseconds, and then out of nowhere, bam, just reaches to 200, 400, 500. Well, something definitely it is wrong over there. And of course, you need to understand so that you can take measures. Also, tools for troubleshooting Azure storage applications. So I have metrics and I have logs. And then I can send that data, and we're going to see that in the next slide, to Azure Monitor. But there is a big difference in terms of what metrics are and what is logs. So metrics, it is a numerical value with the time associated. So it means that, oh, at this minute I was running at 2000 IOPS per second. Okay, then the next minute I was at 3000 IOPS per second. And if we collect data across the day, we can just build one of those charts and try to understand what is happening in terms of performance on our storage account. If I'm talking about logs, well, that means like this file was accessed, then we got an error because someone tried to access this, but it was not possible, and things like this. So that is the logging component. Both metrics and logs, I can send them to Azure Monitor. So Azure Monitor will allow me and enable me to collect, visualize, and analyze, and also to respond to data. Azure Storage can then publish this with log analytics associated. I can build amazing charts with several different other services interconnected with each other so that I can get a complete view of what is happening in my system. In terms of storage metrics on Azure Monitor, again, features that I can have with this, I can monitor charts, alerts on metrics, archive analytics, data into a storage account. I can do stream analytics, data to event hubs. I can send data to event hubs. I can ingest analytic data with Azure Monitor, the SDK. And of course, I can diagnose some of this logs integration also. It's also another possibility that I have. To configure this under monitoring, okay, you have several options. One of them is diagnostic settings. Just need to turn this on and just say, okay, what you want to store in terms of diagnostic information. As a best practice, it's also important to track disk performance of virtual machines. And I can track disk performance again also with Azure Monitor. So it's another possibility that I have. I can get disk metrics reported on a per minute basis. I can have disk reads and write operations per second or bytes per second. And of course, like I said before, I can also add alerts on this so that I can understand if I need to change the tier of my hard drive because my disk currently it's underperform a little bit. So okay, I need to change the SKU so that I can get better performance. Or also the opposite. If I see that I have a disk that is always performing at the most 5% of the capacity, for example, well, maybe you don't need that performance on that disk, so you can choose a lower capacity, again, saving some Azure credits in the process. So, okay, so now it's time to have some quiz questions. So the first question is around Azure files. So imagine that I created an Azure file share in an Azure storage account. Then users in my company, they need to access those files from the file shares from their laptop. So they are in the company network and they need to do this. So what port should be open to ensure this connectivity? And we have port 80, 445, 443, and 21. So this question is more about like, hey, do you know, okay, what port does the Azure file share use? Okay, well, if we look at here, we looked at what? Well, port 80, that's HTTP. Okay, so Azure Files uses the SMB protocol. So it is not that. Then the last one, 21. 21 is from where? FTP, correct? So again, look, that's not the one. And then I get 445 and 443, and they are very similar, right? But the correct answer is 445, okay? Because 443 is HTTPS. Okay, so you need to know this. Second question here. So you're planning to use the import export service to export data from a storage account. Okay, and now my question is, what is the service that I'm allowed to export? Can I export data from a data lake? Can I export data from a table storage, from a managed disk? It is possible. Well, basically the options that we have here is blob, files, tables, managed disks, and file, and data lake. So basically file storage and data lake. So those are all the options that I have here. And there are a lot, and I just need to answer one. Is just one. It is the answer. And well, it's quite a hard one. This you really need to know. But imagine that, and probably some of you that are on that side probably don't know this, but what would be your guess? If you needed to wild guess and do an evaluated guess here, what will be yours? I will tell you the answer right away. The answer is blob storage. And as you can see here, I made a screenshot from the Azure documentation down there. Supported storage types. So if you're doing an import job or an export job, they support different storage services. To import, so that means I have data on-prem and I want to send it to Azure. I can send it to blob storage, but also to Azure files. In the export, only blob storage it is supported. And if we go back here one slide, look, if you see these ones, the more natural one to be supported, it's the most common service one, and that will be blob storage. So that will be a good evaluated guess that you could try to do on this. So there you go. So the answer will be blob storage. Another question here, it's the question number 3 and last one that we have, is I created a V2 storage account. I had uploaded a file called local.png to a blob container. I need to make that file available only during the next 12 hours for someone to access this basically without any authentication. Okay, so just a link and he gets there. So what option will I choose? Will I provide the storage access keys to the developer so that it can just code that? Will I change the container to allow public access? Will I create a shared access signature, or can I implement our back? So role-based access control. So the answer of this one, we just saw this, we covered this, we did some demos on this. So the answer, it is, yes, it is creating the access shared signature. That's what you end up needing to do. And you can set the expiration date from 12 hours from now. And then, yeah, that file will be accessible for the next 12 hours. You can even do this, for example, for just a standard file that you have there. It doesn't even need to be through a web application or something like that, okay? So that will be a good question to explain the capabilities of the SaaS tokens. You can also learn more with some self-paced learning resources that you can find on Microsoft Learn. As you can see here by your screenshot, so there are several learning paths on Microsoft Learn for administering infrastructure resources in Azure, for architecting storage, for architecting compute infrastructure, networking, but also for other topics like containers with Docker, with AKS, with ACI, also with security, managing security operations, and of course, don't forget also managing identity. So research for this learning resources that you can find on aks.ms/learn. So this is the Microsoft Learn platform where you can learn much more about these topics. Don't forget, coming up tomorrow is going to be a day fully dedicated about virtual machines and configuring containers and web apps. So it's a very, very interesting day with a lot of content about compute. It's a very, very cool day. So see you guys tomorrow.
Thank you for sharing your knowledge with us today. I hope our participants will really benefit from it. Thank you to all the participants for joining us. Hope you enjoyed today's session. We'll see you again tomorrow. Goodbye.